Okay, so section 7.6, the last section. So we're going to be using logs and the calculator often for some of these problems. And actually, let me pull up the graphing calculator right now, just so we have it ready to go.
I should probably buy it.
Are you missing yours? Oh, I mean, you can always borrow. I mean, if you want to practice stuff at home, you should have one.
It's very also like for the placement test. I had like the mini ones.
Mhm. Yeah, no, it's not good enough. Yeah. All right. So guys, number one. So number one, actually, you could have done this. Oh, God bless you. You guys could have done this problem before learning about logs. Because what you'd want to do for number two is you could do this. You could change 4 to 2 squared and 1/2 to 2 to the -1. Why do you think I want to do those changes?
So that then you have the same basic.
Yes. So you have the same basis. What were you gonna say, Haley? So it's have the same basis. So I thought you were answering the question. Why we want the same basis? Because if you have the same base, well, just what? Just wait. Just be patient. If I change the bases, right? So you have 2 squared raised to the x power equals 2 to -1 raised to the x minus 3. Now let's use properties of exponents, right? What does the left side become now? 2 to what power? 2x. Yes, thank you, Cam Wiley. And how about the right side? Negative x plus 3. Now, Haley, here's the reason why. I'm going to color code this so that everyone can see.
You just equal them to each other.
If these are the same, then clearly these must be the same, right? If the bases are the same on each side of an equation, then the x must also be the same. So because of that, I can now make the following conclusion that 2x must equal negative x plus 3. Right? So, and just as I'll put this as a text box here. If the bases on each side of the equation are the same, then the exponents must also be the same. And at that point, that's pretty easy to solve. What was that, sorry?
Sorry, what's the arrows pointing to 2x?
Equals negative x plus 3.
Just the exponents.
Just the exponents. Yeah, the arrow might be a little confusing. Let me do this. Let me lasso these right here. Yeah, that's probably better. So then 3x equals 3, x equals 1.
Should we write this big solver?
Yeah, totally. Yep. Really, what you really want to show is this. Hugo, can you stop talking? Thanks. All right. What you really want to show is all this stuff. That's really the solution. These are more annotations, right? I was annotating my own notes, like, hey, but we're changing 4 to 2 squared, changing 1/2 to 2 to -1. And then the text box is just also more annotation, like, hey, you know, if the bases are the same, of course, the exponents must also be the same. But the actual work you're going to show is what you see highlighted in yellow, right? Like, you change a 4 to 2 squared, change 1/2 to 2 to -1. Then use properties of exponents by raising a power to a power. You get 2 to 2x, 2 to negative x plus 3. And because the bases are the same, the exponents must also be the same. And then you just solve for x, right? So that's one way to do it, which actually I would suggest that you do it this way if you have that luxury. If you have that luxury, you totally could do it that way. I'm going to show you another way you could have done number one after I finish number two. Let's look at number two. For number two, unfortunately, I can't really change these bases because 4 and 11 are not multiples of each other. Like 4 and 1/2 are not multiples of the same. I'm not sure what I'm trying to say. Are not multiples of each other. I guess I could say that. That's kind of weird what I'm saying here. But like 4 and 1/2, I was able to change that up to base of 2, right? I can't really do that with this. So here's what I'm going to do. I'm going to take the log of both sides. So it's kind of a creative way of doing the problem. So let me rewrite the question first. If I rewrite the question, it's 4 to the x equals 11 to the x. I'm going to sneak in a log to the left of each side.
But you can do it.
You can do it. It's totally legal. It's not illegal. You totally can do it because you're doing it to both sides, right? As long as you do it to both sides, it's totally fair treatment. Now, do you guys remember the property we have with logs and exponents? What was that property we did 2 days ago? Goes to the front, exactly. Totally rolls to the front. So the x rolls to the front, and this x rolls to the front. So what do I get now? X times log 4. Yep. At this point, I could use a calculator. That's probably a good idea. So let's get a calculator going here.
You know, it's about like X log into the calculator.
What was that?
Like when you're entering in the calculator, just do log 4.
Oh no, you do log 4. You do log 4.
Wait, at this point, would we be able to just?
It's a big 4. So what I'm doing is I'm doing. Let me back up a little bit because Cam asked a good question to Elizabeth. We're using the common log for each side. Remember, common log is base 10. So we're in common log for each side, which is base 10. So if I do log 4, I get it's up.
So cute. Wouldn't it be like,
Yes, you are correct. You're totally a step ahead of me, but let me just do it this way. But yes, you are correct. Yes, it's gonna be 0. But you're totally a step ahead of me. Okay, so you have that. Now, what do you think x is going to equal at this point? If I subtract both sides by 0.602x, if I combine like terms, let me lower my calculator here. Yeah, so if I subtract both sides by 0.602x, you get 0 equaling 0.339, I think.
which is correct.
0.
X is just 0, exactly. Exactly. Now, I didn't have to do it this way. If by inspection, I probably should have just thought like, oh, if I raise both sides to the 0 power, I get 1 on each side. And that's totally fine if you see that and you make an explanation. You don't have to show all this work necessarily. It's rare that I'm going to give you a question like this because I want you to do a little more work. But that's the thing you could do. You can take the log of both sides to solve the problem. That is totally legitimate technique. Yeah.
You just simplify the 0.339.
Exactly. Exactly. Oh yeah. Sorry, Isabel. Go ahead.
If you just plugged in 1,
You mean 0? Yeah, because then both sides will be 1. I mean, if you're able to just see that, because there's no other numbers being added or subtracted or multiplied or anything weird happening. It's just two bases. That's it, right? That are very. Yeah, sure. You could. Now, I could have done the same thing for number 1 if I so desired. I could have done. You don't have to write this down, but I could have done this. I could have done log 4x equals log of 1/2 x minus 3. I totally could have done that. X times log 4, x minus 3 times log 1/2. I totally could have done that. Log 4, Patrick, can I borrow your graph calculator, please? Thanks. So log 4 is going to be 0.602x. Oh, come on, here we go. And log 1/2 is going to be negative 0.301 times 3, which is going to be plus. Oh, please silence that. Thanks. So when I move things around, I get this. Thanks, Patrick. Appreciate it. So just so you know, an alternative method for doing this problem could have been taking log of both sides also. And why do I have that luxury? Because logs isolate exponents. This is why we have logs in the first place. Now you can solve more equations. Now that you've opened your broadened your horizons, now you can solve equations where you couldn't solve them before. Now you can solve for an x as an exponent. Because how do you remove the exponent? You log. logs are inverses of exponents. We've talked about this for the last few weeks, right? Or 2-3 weeks. So I could have done that, use the calculator to get what log 4 is, use the calculator to get what log 1/2 is, have these nasty decimals, combine like terms, you get the answer.
Wait, why is it 0 point?
That's just what happened when I multiplied this to -3. This right here, by the way, was -0.3. I kind of glossed over that. We distribute -0.301 into this, that becomes positive 0.903. You have to use a calculator for that part. That's not terrible, obviously, so I'm sorry I glossed over it. But that's what we're gonna do. We're gonna be using logs to solve these equations. So let's move on. Now let's look at number 3. Now number 3 is a little different because a log is already given to you. Now look over here.
Is that the same? You can just take that.
Yes, exactly. Yes. Because there is exactly 1 log on each side and nothing else. Then we can drop the logs as long as the bases are the same. Totally could do that, 100%. Let me resize that. So in this case, what am I going to say? I'm just going to say this. Right? That's all. You get 3x equals 12. X is 4. Totally, right? And one thing I'm going to advise that you guys do, actually, I'll tell you this on a test as well. Let me put a text box again down here. You must check for extraneous answers. So there is a possibility that when you plug 4 back in, it may not work. Really, what you're looking for is a negative underneath the log, or negative inside the parentheses, because you can't log negative numbers, right? Like, for example, what if I log base 2 of -2? Is that possible? Can I raise 2 to some power? Can I raise 2 to some power and have it equal -2? No, because 2 is a positive base. So you have to make sure you're not logging negative numbers. That's really what you're checking for when you check your answers. Not so much the left side equals the right side like we did with radicals. It's really more you can't log negative numbers. So we'll see that actually occur for a future example. But this was really easy because the logs just dropped off. I won't give you one this easy on a test because I'm going to check to make sure you know the properties of logs. So let's look at number 4. Hey, go ahead, yeah. Exactly, the subscript of the log. Right. Now, if they were different, you'd have to use some more creative techniques, but I'm not going to do that to you guys because you guys are just learning about logs. You'll have the opportunity to pre-calculus do the more advanced stuff. Okay, let's look at number 4. Now, in this case, I would say convert to an exponential equation. How would I do that conversion? Do you guys remember?
4 to the power 3 just 5x.
Perfect. Thank you, Hugo.
Actually.
Remember, the definition from the base. The definition of a log is this, right? If you have log base bx equals y, then b to the y equals x.
Remember decimal is that?
Remember that, right? That's
okay.
I got
Actually, no, it shouldn't be decimal, it should be 13.
I got 12.6.
Well, you get 64
And then -1 is 60.
No,
Plus
plus
one,
one,
that's why.
plus one.
plus 1, dude. Yeah, you had 63. Yeah, you're just careless there. So x equals 13. That's all. So what I just did was I did the definition of a log, right? What was the definition of a log? You swap two numbers or two terms. You swap the 5x minus 1 and 3, swap them, and you do 4 to the third power. Remember, switch these two, and the 4 gets risen to the 3 power. 4 gets risen to the 3 power, that's 5x minus 1. That is the whole essence of this unit, right? Log base b x equals y is x equals b to y. That is the whole essence of this unit. Okay, we're okay? Yeah, good.
You just have like here where it says
Hmm?
2x.
I haven't worked out. Let me work out. Cool on here. You're way ahead of us.
It's just like, it's not even, it's the actual.
We'll just move on. Hold on. Okay. All right, here we go. Let's do this problem here. Okay, so first off, the base. Not yet. Here's what we're gonna do. So common log is base 10. Both these are common logs. So what's the first thing I should do with it? I see 2 logs being added, right? What property did we learn on Wednesday?
Combine.
How do I combine them? How do I combine, guys? What property? Multiply. Yes, good. So what you need to do is condense the 2 logs. You could have moved one log to the other side, but then you have that 2, right? And that makes it kind of weird because you can't then drop the logs. If you didn't have a 2 and they had a 0, then sure, go ahead and move one logs over and drop the logs. You could do that. But condense the 2 logs as 1. And how do you do that? You do like this. 2x times what? Yep. God bless you. Do you guys see how I did that? That's kind of a key step. That's using the properties. That's why I cared about condensing 2 days ago and why I gave you guys so much practice. So you guys get used to knowing how you can combine these, right? So it's log of 2x times x minus 5 equals 2. Now, first off, what's the base here when you don't see a base? What do you assume it is? 10, good. So what's gonna be my next step?
Oh, are you gonna?
Yep, you're gonna flip just like in the previous problem. Hold on a sec. Let me shift this.
Because that's the base.
Just need a little more space here. Okay. So let's do it. 10 squared equals 1 on the other side, guys?
2x squared minus 3.
Yeah, and then you could distribute, right? And do 10 squared. And then do this. So see how I got a little sneaky here? I love this problem. This is actually my favorite problem. This 2. I asked about this 2, AJ. You see it now?
Yeah.
Yeah. So this was a question.
I understand.
You got it? Yeah, I just swapped these 2, right? I swapped these 2 like in the previous problem, like we did for value logs in general. And then you drop the log. Now, I love this. Hold on a sec. I'll get a question. I love this problem because it's forcing you to use stuff from the fall semester. This is a sneaky way of me still assessing quadratic functions because you're gonna have to factor this, right? So this is actually one of my favorite problems. Definitely expect this in our test, something like this. Now, Patrick's question.
Oh, that was my question. If this was like a test level.
Totally, 100% it is. Yes.
Like the equals, the 0 on the.
Well, over here.
Yeah.
No, I didn't get rid of it. This 2 comes over here. This 2
Oh.
is attached here.
Okay.
Yeah, let me highlight it so you guys know where we are. So this right here is right here. And then this right here is right here. And this right here, let's color code. Does that make sense how I did the swapping? So and I'll I'll tell you how I would score this on a test, just so you know my thought process. But at this point, now you're just solving a quadratic, right? Which I know you guys can do. I'm gonna factor 2 out. That's always a good idea. And then what would I do after that?
Generic rectangle,
Well, sorry, so go ahead.
generic rectangle,
Generic rectangle.
it's like where you put like X squared.
Oh, I know what you're talking about. Yeah. I'm just gonna just factor it straight up. But yes, I know what you're talking about. I messed up. Should be at minus 10. My bad. So what was X equal, guys?
Wait, Mr. Ethan, is it okay if I did the factory, but I got like back to the number?
That's fine. It's just that it's easy to pull 2 out.
But I got the same.
Sure, that's fine. You get 10 and negative 5. However, negative 5 is not okay. You can't log. Hold on a second, let me change colors.
No, well, negative.
You log 0.
Nope. Yeah, you can only log positive numbers. Actually, I can't log negative numbers or 0. I'm glad you brought that up, Wiley. Thank you. Yeah, you can't log because if you have like log negative 10, that's weird because that's base 10. So 10 to some power equals negative 10? No way, that can't happen. You can't multiply 10 over and over again and make it negative because 10's positive. That can't happen. So negative 5 gets discarded, but 10 is okay. 10 will work. Another thing I needed to say about this, how would I score this problem? So how would this actually be scored? I probably would do this, just so in case you guys are curious. I'll probably make this part worth 2 points because you have to combine the logs. Actually, no, I lied. I'd probably make that worth 1 point. This right here would probably worth 2 points. That's kind of a big step because you have to know how to shift things around. And then all the algebra at this point would probably be worth probably another 2 points, maybe more. And then getting the final answer probably worth 1 point. So that's how I would divide up my points. So you have to know your log property. You gotta know the definition of log. You gotta know quadratic functions. And you gotta know the check answers. I love this problem because it forces you to use so many different skill sets. 6 point problem. I'm giving you. I'm showing you how I grade each part of the problem. No, I don't believe that. No, what? No, each step. I'm giving the points for each step. That's what I'm doing. So. Yeah.
This is the last.
Exactly. So that's what we're just reviewing next week.
Okay, so
It's actually gonna be probably worth a little bit more because this is more involved. So it's gonna have a little higher weight, I think. I have to double check. I think it's gonna be 50 minutes for sure. Yeah. 5-0. Yeah. So yeah, that's what we're doing. This is probably the most essential topic we covered this semester. Chapter 8 can be hard too. I would say chapter 8 is probably a little more challenging because it covers more content. This is a little more abstract for sure. I'd say it's the most abstract thing we're doing for sure. But once you see the movement of stuff, you'll be fine. All right, so I'm all done with the lesson today. What I want you guys to work on now, I'm gonna stop recording.